Hello, everyone, and welcome to Past and Future of Enterprise Wireless. I'm Greg Gottman with Solona. Today, we'll be talking about several things: DAS, small cells, private LTE, Wi-Fi, 5G. But really, it's a culmination of where we've come from, where we're going to, and how we're going to get there. I'm joined today by three individuals. Mehmet Yavuz, who is the co-founder and CTO of Solona. Also, Dr. Boo from CTS, who's going to walk us through several items that I think you'll be interested around deployments, and Jamel Ramul from IB Wave, who has extensive experience in this department. I think you'll find that he has plenty to say, and hopefully you have plenty of questions for him as well. Before we get to our speakers, however, we do have some housekeeping. So with this, it's really around making sure that you get the most out of this webinar. First, you can submit questions anytime during the webinar in the screen to the right. Also, feel free to chat with each other or with us. We'll interact as best we can during the webinar. In addition, there are two polls that will be asked of you, multiple choice for them. They will help us with the Q&A piece and also hopefully help inform not only ourselves, but also fellow attendees around what your interests are or where you're headed around this technology. Make sure that you come back at any time to view this again if you'd like. This will be recorded, and you will receive an email with the replay link. And if you'd like more information, please feel free to visit us at Solona, at our website, also CTS and IB Wave at their websites as well. There's plenty of information all around for everyone, so please drop in. Now that I've delivered the housekeeping, I can hand over to Mehmet Yavuz. So Mehmet, if you wouldn't mind jumping into a brief history of enterprise wireless.
Hi, everyone. Thanks, Greg. It's a great pleasure to be part of this webinar. Yeah, in this first part, I will provide an overview of the enterprise wireless and go into some specifics about CBRS LTE. Just as a quick background on myself, I have been in the cellular wireless communications for over 20 years. Most of this time, I was at Qualcomm corporate R&D, working on design, development, standardization of the cellular wireless, such as 3G, 4G, and 5G technologies. In early 2019, I joined Solona as a co-founder and CTO. And at Solana, we believe modern cloud software stack will really make the LTE and 5G technologies accessible to enterprises. And we deliver a complete network platform from the APs to the edge platform to the orchestrator and manager of the network as an end-to-end solution that delivers guaranteed service levels for business critical applications with the 4G and 5G. And by the way, when I say enterprise, I mean all kinds of enterprise verticals, including both carpeted enterprise, such as offices, universities, and also non-carpeted enterprise verticals, such as industrial verticals, warehouses, retail stores, and so forth. I always like to put this explanation in the beginning because we'll keep saying enterprise throughout the rest of the webinar. So having said that, maybe we can move to the next slide. So yeah, here let's first take a look at different wireless technologies in the enterprise space. Traditionally, mobile network operators have been deploying cellular networks such as LTE as a wide area macrocellular network, right? With big base stations, antennas on top of cellular towers and so forth. And however, as we all know, there's usually a wireless coverage problem indoors, right? And many enterprises suffer from this. And there has been multiple solutions for this over the years. One solution for this problem is distributed antenna systems, or DAS, where typically a mobile network operator will bring their signal or a base station equipment to the basement of a building, and then cables will be run from that location from basement to different places inside the venue or the enterprise. And usually this dedicated cabling installation and all that is very costly and only provides improved coverage without any capacity. So you may see like 5 bars on your phone, but you may still end up getting a very low data rate because you're sharing that capacity with everyone. And besides, enterprise IT departments usually don't have any control or visibility of the performance or the usage of the network. So there are these limitations for DAS. And then another solution that happened over the last decade or a little bit more is small cells. where basically an MNO installs a small cell, which is essentially small base stations inside the enterprise. And these solutions provide not only coverage, but capacity, because you have multiple small cells there providing capacity. However, these cells are typically deployed as a separate network with separate backhaul and cabling without using the existing LAN. And this increases the cost. And furthermore, each MNO needs to deploy their own small cell network in the enterprise, which further increases the cost and complexity. And again, enterprise IT typically don't get control or visibility to this network. So now coming to private LTE, basically with the availability of local private spectrum options like CBRS, now enterprises finally have an option to deploy their own private LTE networks. And this enables enterprise IT departments to have a separate network than Wi-Fi as a wireless network, fully under their control, which brings all the technology benefits of LTE. And this essentially means predictable wireless for critical infrastructure on the CBRS spectrum. Of course, you're all familiar with Wi-Fi, and Wi-Fi provides capacity for many devices in more of a best effort manner, with good capacity, enabling density with all the enhancements of Wi-Fi. And last but not least is the exciting opportunity with private 5G is that there's a strong roadmap of LTE, private LTE deployments evolving into private 5G. And this will enable many new devices and next generation applications. So having said that, moving on to these technology aspects very quickly, one key question in everything I showed so far is what is the technology comparison between Wi-Fi and LTE? And we really see these technologies as complementary. LTE brings some benefits to Wi-Fi. One example is if you go through the layers on the first layer, on the physical RF layer, basically you have higher transmit powers and better sensitivity and hybrid ARQ, which really uses the wireless link more efficiently. At the end, results in better coverage with the private LTE deployments per AP. You may get, 3 to 4 times better coverage indoors. Outdoors, it may go to 10 times or more. Mostly based on the transmit power levels allowed. The other key aspect is in the layer 2 or the access layer to the medium. Wi-Fi has the CSMA CA type approach where there's a clear channel assessment. LTE is different in that sense. There is the coordination of the transmission across different APs with a very scheduled transmission. So that helps with the quality of services for different applications, for latency, throughput, and bandwidth and packet error rate. On the authentication layer, Wi-Fi traditionally have cert-based credentials. With private LTE comes SIM-based credentials, which helps a device-based credential specifically allowed with the SIM. And that also allows eSIM with remote provisioning and so forth. And mobility is another important area. On the Wi-Fi, everything is really driven by the device side. On the LTE and, of course, 5G as well is where infrastructure controls the mobility. And this, again, helps to the guaranteed SLAs with no packet loss and seamless handover events as the device are mobile in the environment. So all of these things rely on a clean spectrum for LTE, all these benefits. And next, we'll get into how this is achieved in the CBRS band. How do you get a clear interference-free spectrum in these deployments? And let's just have a quick review of how that works. Basically, WinForum and CBRS Alliance established this framework, which is all now commercialized with multiple vendors. And what happens is when you install a radio or an access point, it registers with a spectrum access system in the cloud. And there are multiple companies providing this service. And it provides, the AP provides its location and the transmit power. And then the AP requests spectrum allocation for its operation. And at this stage, the SAS, the Spectrum Access System, looks at its database, the propagation model based on the train, of that neighborhood, and then looks at the allowed channels in that location and provides a list of allowed channels for that specific access point in the CBRS band to operate. So then at the third step, the AP requests specific channels for its operation, and the SAS allows the use of that channel and puts that in the database for other APs in the vicinity to know this specific location and operation. And at that point, the radio starts operation. And on an ongoing basis, the SAS monitors the spectrum usage and manages these channel assignments. And this is done more on a slow time scale of once a day. But the bottom line is this whole operation is done in the background. It doesn't affect, there's no manual intervention and so forth. It's all automated, and it kind of enables really plug and play deployment model without all the detailed planning. And the operation is guaranteed to be interference-free and predictable performance. Now, once you have these deployments, and an ongoing discussion with customers we see is a trend for forming these critical applications and devices converging on a single platform. When you go to enterprises, you will see there are multiple networks sometimes for different applications. And with LTE, with the quality of service and predictable performance, there's a trend to bring all these different applications on converged platforms. So this is another advantage of private LTE beyond the coverage and the predictable performance that I mentioned. And just as an example, here we picked the Samsung Galaxy X Cover Pro as one example. And this is a ruggedized Android smartphone designed specifically for enterprise. And there are a number of enhancements on this device which makes it especially appealing, including a programmable side button, which is excellent for PTT applications. And another thing to highlight is Office 365 that Microsoft recently announced that Teams will soon add support for PTT. Our VP of Marketing, Özer, has this device testing right now. And what we also see is you can assign specific applications to use CBRS network. And this means that you can keep your critical communications and enterprise applications on this private LTE network, while other applications with lower priority, for example, can simultaneously use Wi-Fi or carrier network. So this is just one example again, but the ecosystem is really healthy and driving these kind of innovations and ability on the device side as well. So now, beyond what is really happening in the ecosystem with the commercial private LTE deployments happening right now, how is the roadmap, right? How is the future looking? And that's looking really exciting. Essentially, the 4G LTE is already evolving into 5G NR. 5G brings a lot of new capabilities, such as more bandwidth, low latency, and more spectrum. And we see these deployments really coming starting later in 2021 and scaling in 2022-23 time range. And the important benefit of, again, LTE is this roadmap, which is driven by the 3GPP Standards Organization. And just to hit a few of those key enhancements that's coming with 5G, first of all, reliability will increase to 5 nines with the initial 5G deployments in release 15, and then it will go to 6 nines type reliability, which is really getting close to the wireline type operation. Latency values also improve from about 20 millisecond latency we see with LTE today. Now with 5G, you can go down to 5 milliseconds or even 1 millisecond with release 16. Higher data rates, gigabit data rates are available with the larger bandwidths from 100 to 400 megahertz channels. Also, there are additional spectrum options opening up with 5G in different bands, including millimeter wave bands. And there are improved radio techniques with spatial diversity, coordinated multi-point transmission of base stations that again helps to achieve this ultra-reliable, low-latency communication. And also 3GPP is creating a path for further applications with unique capabilities, such as factory automation and so forth, with things such as time-sensitive networking and internet, like industrial internet replacement. So all of those are the exciting things coming with 5G. And in terms of use cases, we talked a lot about private LTE and 5G, but I want to highlight another key aspect, which is how do you serve devices which go in and outside of the enterprise? And we categorize these devices into three buckets. The first bucket is these truly private devices, which really don't leave the facility. These are enterprise-owned devices in the facility. But then there may be other devices which are maybe enterprise managed, but the employees or some vehicles coming in and outside the enterprise facility needs coverage when when they leave the enterprise premise. And those devices are now available with dual SIM capability. So you can put, for example, two SIMs, one from the operator, one from the CBRS LTE network, so that these devices, when they come into the enterprise, they can go to private LTE 5G network. When they leave the enterprise, they can roam to the macro network operator. And then there is this third category, is really unmanaged, bring your own device category, where it may be the customers or visitors coming to the enterprise. And we see those devices being served by the CBRS LTE 5G networks, but that requires some kind of interface to the operator on the background. And that part, this third category, is in development and trials at this point. So bring it maybe all together. If you move to the next slides, it always helps to put these things into some perspective. I'm here showing the timeline of the major phases in the enterprise wireless space. Basically, the first generation of Wi-Fi up to about 2003 was kind of the initial phase. But then once the Intel Centrino chipset made it part of every laptop out there, it suddenly became an must-have for every laptop. And about in 2008, there was another important jump where all the smartphones, namely, iPhone and others, made Wi-Fi part of their offering. And then we saw the Wi-Fi truly became a must-have in the enterprise. And honestly, during the last decade or so, there hasn't been very significant change in the wireless network architecture. But now with the advent of the CBRS and private LTE, we believe that we have a new generation of wireless networking that's starting in the enterprise space, and really excited about that. But at this point, I will just conclude my talk, and I'll give a chance to Greg to talk about the poll questions, and then Doctor will continue after that.
That's right. Thank you very much, Mehmet. Hopefully everyone enjoyed that. And please feel free to reach out to Mehmet on social media as well. He has a presence there and also on his YouTube channel. For the poll question, in thinking about what Mehmet just presented, which technology are you most likely to invest in the upcoming quarters or years? Now, the poll questions should pop up on your screen on the right-hand side. You can choose as many as possible, or many as, I guess, are reasonable for you. Feel free to pop those in right now. And we'll use that for discussion towards the end of the session. So let's keep moving on as you're doing your voting into the next bit, which is Dr. Boo speaking about DAS and CBRS deployment examples. So with that, I will stop sharing, and Dr. Boo, you are free to share.
Thank you. Honored to be part of this webinar, and really excited about sharing some of our DAS and CBRS examples with everyone. So first, I'd like to really a brief introduction of myself and CTS. So CTS is Communication Technology Services. We're based out of Marlborough, Massachusetts. And the company actually this year is our 30th anniversary. We have been focused on a lot of services and solutions. We're nationally full service system integrators focused on DAS, small cell, public safety, Wi-Fi, and also the new emerging technologies such as fiber-based LAN solutions, private LTE, CBRS solutions, as well as some of the other services that we're providing to our customer, consulting, general contracting, monitoring services, and the maintenance services, structured cabling, and also provide different funding options. So our mission is really become a trusted partner for our infrastructure needs and our for your infrastructure needs and helping guide you through the ever-changing technology landscape. So I think with our experience and our labor force in national presence, we can help you to solve your wireless enterprise needs.
Hey, Dr. Boo, for those of us, we're seeing a screen a little bit smaller. If you want to present full screen.
Sure. Hold on. Okay. Is this better now?
Yes. Thank you.
Sorry about that. One of the reasons we have been successful is our design center in Phoenix, Arizona. So in that place, we have a 24/7 operation there. We have over 40 designers who are focusing on deliver a design to meet customers' needs. So we're using the software to create 3D and RF modeling for different solutions that we're providing. That includes carrier-grade cellular Wi-Fi solutions, medical-grade cellular Wi-Fi solutions, enterprise class wireless voice and data systems, and also public safety, CBRS, private LTE networks, and SD-LAN. Those are fiber-based software-defined LAN network solutions. So here are some of the examples of our modeling and our heat maps and some of the solutions we're providing. Next few slides, I'm going through some of the DAS deployment and CBRS deployment examples of actual buildings that actual project we're working on right now. So one of the biggest enterprise verticals CTS is working on is commercial real estate. Nowadays, a lot of the office buildings like office buildings, hospitals, and hotels, they require improved wireless connectivity within their facilities. So they're trying to deploy converged infrastructure support, not just wireless solutions. They also want to support all the other building management systems. So this sample we have here is a commercial real estate in New York City, and we're designing for their cellular, public safety, Wi-Fi, and two-way radio systems. So one of the considerations to put into the system to make sure that system is upgradable to support 5G new radio standards for the low band. That means the system has to be able to support any frequency from 600 megahertz to all the way to 6 gigahertz. And in order to reduce the initial cost, we try to deploy this in two different phases. First phase is really to deploy the core with head-end equipment and all the public areas covered. That's the picture shown on the left-hand side. And then when tenants moves in, we're going to build out their space on a later date and to meet their different needs here. So on the right-hand side, you see some of the modeling pictures as well as the actual building pictures. So we're trying to make sure that our model really accurately reflect the actual building. Next example that we have done is actually a facility, hospitals in Oklahoma. So healthcare vertical has include hospitals and medical office buildings. They are increasingly demanding better wireless connectivities. So one of the main driving factors of these facilities are their coverage indoors and capacity needs for the customers and their their doctors and physicians and all the nurses. The other one is the data throughput requirements for their facilities. A lot of these hospitals nowadays are using high data, the videos and or some of the AR, VR, tools to help their physicians to operate or to send data, patients' information back and forth. So they require a lot of wireless connectivity within this facilities. The challenge for the hospital is that they have RF-friendly materials. Usually there are a lot of heavy concrete lead walls, so the signal doesn't propagate well within the building. So make it a very RF-friendly. So we have to design it much more dense than the typical commercial real estate buildings, and we have to come up with some creative ideas to put the antennas or put transmitters in places that where you can penetrating or you can have better coverage than you normally would be able to achieve. And then the other one challenge within the healthcare and hospitals is the installation environment, because they usually have requirements for tenting, for cleaning up before and after the installation, and also patients are there 24/7, so you have to work around the schedule over there. So it makes it very difficult for us to deploy our systems. So we also, in those environments, we also design typical solutions for hospitals, include cellular, DAS, Wi-Fi, public safety, and two-way radios. And a new development recently happened is to deploy a 5G millimeter wave radios for the public lobby areas. Those are being deployed in multiple hospitals right now, so that the customers who are waiting in those areas can achieve, can benefit from the high data throughput and be able to share videos, share some of the applications when they're waiting or pick up their relatives during those times. Another new development that we are really focusing on is the CBRS deployment. This example I'm showing you is actually one project we're still working on. We actually have design and proposal approved beginning of the year, but the deployment actually been delayed due to COVID-19 situation. So I want to share with you what we have done in this particular example here. As I mentioned earlier, the CBRs, or in the previous section of this webinar, CBRS is used to provide private network for the customer, and that's not your typical cellular voice and data applications. In this particular case, we're trying to develop a system for venue operations, also to support IP-based security cameras and some of the IoT sensors in this particular, in some of the special coverage areas. So in this particular shopping center, the coverage inside the stores are not really the concern of the operation of the shopping center. They are concerned the coverage outside, the alleyways in between buildings. So that's not your typical, cellular deployment or Wi-Fi deployment. This is a very private LTE use cases. So in this particular example, we choose to use category A, CBRS category A, CBSD radios. Those are 30 dBm alpha power radios, and then they can support up to 2 times 20 megahertz channels in this particular case. And by FCC rule, the CBSD cannot mount more than 6 meters above ground when this category A CBS are used outdoors. So there's a lot of limitation to for us to find the proper location or proper way to deploy the CBRS CBSDs. So next is some of the examples where we have surveyed and figured out where or proper location to hide and mount those CBSDs. So the picture to the left is showing a high-end, actually there's a high-end car dealership one of the IoT applications is to be able to uh, sense the the oil and battery, oil leak and your battery situation in this particular high-end car dealership. So because they have a limitation where they cannot allow any installation in their facility. So instead of mounting anything on the building, we decided to put the Class A CBSD in the bollard and mount next to the tree, so people go by will not notice it at all, but will provide enough coverage for this facility. And then the next two pictures on the right really show where we try to hide the CBSD under the facade or under the wall. This is to provide coverage for the alleyways and also provide coverage for the storefront, not necessarily to provide enough coverage for the store inside. So this is a very unique application that we have running into. Like I mentioned earlier, this is really for the private use of the shopping center operations. So next couple of slides really going to show the simulation results when we designed this in IBWave. And as I mentioned earlier, this solution has not been implemented yet, but we're hoping that in the very near soon, once the COVID situation improves, we'll be able to implement this solution in the near future. So this picture shows the coverage plot of the shopping center. As you can see, the focus is really on the outdoor areas, not so much on the store itself. And the color represent the different signal levels. Then the targeted coverage is NEC 95, which is a light cyan color. The dark purple color, really, those are the store inside. Next slide really shows the SINAR plot, which is the signal to noise ratio. And really, you can see that in order to achieve good throughput, we're targeting as 8 dB SINAR that converts your data at about 20 megabit to 30 megabit per second download speed. So as you can see, most of the outdoor areas that we target achieve that signal level or that SINAR levels. So that concludes my part of the presentation. I'm going to hand it over to the next presenter.
That's right. Let me give him one poll, if you wouldn't mind, Dr. Boo. I'll share that real quick. And there we go. All right. The question is this: what are the key factors as you consider LTE coverage in your environment? Again, like last time, feel free to pick as many as are applicable. They go through extending the mobile operator connectivity indoors, tech architecture ready for the enterprise IT ownership. You can read the rest. I won't butcher them anymore, but please feel free to answer as many as you feel are appropriate for you. With that, as you're answering those poll questions, I am now able to hand over for our last presenter, but definitely not least, Jamel Ramul from IBWave around designing LTE 5G wireless networks in the enterprise. So Jamel, I will stop sharing and give you the stage if you'd like.
Thank you, and welcome everyone. Glad to be here presenting to you. Let me just share my screen here. Okay. Okay, now that we saw some of the concept and some of the deployment plan by CTS, let's talk a little bit about designing the private LTE or 5G in enterprise environment. And basically, if you are used to do cellular, what are the differences in CBRS, since now you have more channels? We're talking about 15 channels available. And if you're used to do Wi-Fi, what are the concepts from Wi-Fi best practice you could use in designing LTE 5G? But first of all, a little bit of background. So Jamal Ramour, sales engineer at iBwave. I've been in the wireless industry for more than 15 years now. Before joining iBwave, I was working with a carrier in Canada named Rogers, where I was doing DAS and small cell design using the iBwave tool. And iBwave is basically the standard tool for designing wireless network. Doesn't matter what it is, LTE, 5G, Wi-Fi, public safety, IoT, fiber networks, even cable networks. So we've been around for 16 years now, and I'm going to show you what you can do with this tool to design. But I'm going to start with some historic use case. 5 years ago, when I was working at Rogers, we had to deploy a solution in an arena in Canada. And those of you working in the cellular space, you know that usually you have limited channels available on different bands. And then what is done is that all the channels are put together on the same sector and then distributed within a DAS, so multiple antennas. And if you do small cell, then 2-3 small cells with the different bands are connected to the antenna. So you keep this idea of a sector. So this is the arena I was talking about, and the idea how was at that time, how could we apply Wi-Fi best practice to do an LTE design? And in Wi-Fi, for example, in the 2.4 gigahertz, you can use 3 channels, channel 1, 6, and 11, and try to minimize the interference between the different access points. In LTE, the channels are limited. You don't have that many channels. In this example, we had 1.9 gigahertz, 2.1 gigahertz, and 2.6 gigahertz, so 3 channels available. Traditionally, we put all channels in a sector. You put maximum capacity with big coverage area, but there is a problem with that because the edge of the cells coverage or the sector coverage will be bad because you get interference with the other sector. So the idea was, how could we apply Wi-Fi best practice and separate using small cell and smaller coverage area and using one channel, and then separate, like do the same as it's done in Wi-Fi. And the result was an improvement in SINAR from an average of 10 dB to 14 dB. And we're talking high capacity venue here. So it was really good result. So the first learning here is that, yes, you could apply Wi-Fi best practice to small cell design. Since now in CBRS you have so many channels you could use, so separate them will improve the SINAR. You would have the cell parameters, another channel, so your SINAR will still be good. You don't have this interference that will be so high. Now, some of the basic best practice, if we compare Wi-Fi to LTE, for example, the minimum coverage in Wi-Fi, we're talking something better than next 65 dBm. In LTE, we talk, we don't check the RSSI, we check the RSRP. And the RSRP, usually we target something higher than neg 105 dBm. If we want, if we're targeting high density coverage or high capacity venues, then in Wi-Fi, we're targeting better than neg 55 or neg 50 dBm as RSSI. Same apply for RSRP in LTE. It would be neg 95 to neg 90 dBm. The 5G would be SSRSRP. It's another KPI. So noise and interference in Wi-Fi, usually a SNR of 25 dB or higher is targeted. And in Wi-Fi, there is CCI, which is co-channel interference. How many APs are transmitting in the same channel, and there is a minimum CCI that is required, let's say 3, 4, or better, depending on the band, if it's 2.4 or 5 gigahertz. But in LTE, there is no such thing as co-channel interference. There is SINAR. So the interference is included in the SNR calculation, and usually we target something higher than 10 dB. Now, if we talk output power, usually in Wi-Fi, it is recommended to match client power or device and end user device power, which is in general about 10 dBm ERP. So you want to match that power because you don't want to cover a big area with your Wi-Fi access point. Let's say if you put maximum transmit power 23 dBm, and you end up with like 13 dBm mismatch, so the uplink will have 13 dBm gap. Whatever RSSI you get on the downlink, you get 13 dBm less on the uplink. And somehow same apply in LTE, but here we're not talking about matching the power, we're talking about the power imbalance. So wherever uplink, downlink, link budget, try to keep something lower than 10 dB imbalance, because if you're transmitting too high, and then we know that the smartphone usually are limited around 23 dBm, you don't want to get the smartphone to have a link budget that is too low compared to the downlink from the small cell. If we go to some other best practice, when we talk about channel width in Wi-Fi, and here we're not talking about Wi-Fi 6E or the new 6 gigahertz channel or band, we're talking about 2.4 and 5 gigahertz. It is not recommended to use wider channel. The reason being, in 2.4, the CCI will not allow you to use that extra spectrum anyway. And the other reason is that in Wi-Fi, once you increase your channel width, you cannot increase your output power. So the output power is limited, it's fixed. So when you're increasing your channel, basically you're doubling your channel, you're also doubling your noise. So if you can't increase your power, then your SNR will degrade by 3 dB each time you double your channel. So if you're using an 80 megahertz or a 160 megahertz channel, keep in mind that your SNR will degrade by 6 dB or 9 dB, since each time you add 3 dB once you double your channel. In LTE, it is recommended to use wider channel. And CBRS, you could transmit, I believe 30 dBm indoor per 10 megahertz channel. So if you're using 20 megahertz channel, which is better, you could transmit 33 dBm. So you are allowed to add this 3 dB output power. And also LTE is just much more efficient when you use wider channels, so you don't lose resources for the reference signal and for other guard band and stuff like that. Now, channel planning. We talk about using channels in Wi-Fi, especially in 2.4. It's recommended to use 1, 6, and 11 and not check the other channels because they are overlapping. You want to use non-overlapping. In LTE, you will not hear about the term channel. You will hear about the term EARFCN, and the numbers are quite odd. So keep in mind that this is the numbers you're going to deal with. And then same thing here. You have non-overlapping channels. In terms of mobility, in Wi-Fi, since it's handled by the device itself, during the design, we always make sure that there is an overlap between the APs for the roaming, so the device can roam from an AP to another AP before the signal drop. In LTE, since it's handled by the infrastructure, so by the small cells itself or by the EPC, it's depending on the criteria you define, but basically we're talking about channel reselection. So the device will switch from a channel to another channel based on some criteria, let's say minimum signal level or a minimum SINAR, or sometimes based on RSRQ, which is another KPI we didn't talk about. And then it will switch to another channel which has better KPI. Or we talk about PCI handover, and in this term we're switching from a small cell to another small cell with a different PCI. Lastly, in iBwave, there is something we call predictive modeling calibration, and we do recommend doing that if you want accuracy for your design. In Wi-Fi, there is something called AP on a stick survey. So you put an access point on a stick, you turn it on, you do a survey, you capture the RSSI in your floor plan, and you load that in iBwave, and you calibrate the prediction versus the survey, so you have a template to use for your prediction. And same apply for LTE. You could do what we call CW test. If you have access to a small cell, you could do it. But CW test is basically injecting a signal into an antenna and then measuring that signal, and then reproduce the design in iBwave and then calibrate it. Here we have an example we did with Celona a few months ago in February, I believe, during the WLPC, which is the Wireless LAN Professional Conference. It was in Phoenix, pre-COVID. And we had the conference building that we modeled in 3D. And one of the challenges that we only had this floor plan, and then we had to guess the materials, right? So then we modeled the building in 3D. We put the Solana small cells, or whatever you call them, CBSD or eNode B or LTE AP, and we did the design. And you can see the coverage, the target coverage for neg 105 dBm for 2 small cells. And if I want to see the SINAR for 2 small cell, even if I'm using the same channel, which is like the worst case scenario, I have very good SINAR because it's just two small cells. It's just the between the 2 small cell here, the SINAR is bad. But if we start using more, now I have 4 small cells using the same channel, then my SINAR is very bad. It degraded a lot. This is why having different channels, if it's possible, then you see how SINAR is better. Now, one question that came back a lot was how to do survey or how to do measurement for CBRS or for private 5G or private LTE. Those of you work in the cellular space, you know that most of the time we use a scanner. Wi-Fi users, you know that you could use your own device or you could use a laptop with a dongle or something. But what we did at the WLPC conference is that we used a scanner, and that was me using the scanner, walking on the floor and collecting data. And that was the Solana small cell or CBRS small cell. So the solution used, basically we used the mobile app. So this is, let's say, what is available to do CBRS or basically LTE or 5G coverage mapping or survey. So these are the list of the tools that are compatible with iBwave, and you could either manually import that into iBwave Design, the PC or desktop version. Some of them are always manual, and some you could do automatic import in iBwave Mobile Planner, for example, which is an Android device, which is more user-friendly and lighter to walk with. So this is what we use. We used Mobile Planner, and then we used the scanner from one of the tools. And we collected the data. So it was looking like this. This was the data collected, and this is the heat map generated. So this data can be used. Since we had 2 small cell installed, we could collect the data, compare it to the prediction, and then auto fine-tune the propagation model and have accurate wall losses. And then we could create a template to do the what I call the what if. So what if I move the small cell? What if I add? What if I change the power, change the orientation, down tilt? So that's some of the best practice. If you really want accuracy, then you check that. And if you want to learn more, I actually had a presentation during Wi-Fi Trek last year, and this is the link where I was talking about why it's important to have accurate prediction, so you don't need, you avoid having to over design basically if you're putting too much hardware. That was my presentation, and then I think we can jump to the questions if there is any. Thank you very much. I hand it over to Solana.
Fantastic. Thank you, Jamel. I really appreciate that. Let me go ahead and share. All right, so first, I'll address the poll results. So in the poll, what we found, the first one was, what are the key factors as you consider LTE coverage in your environment? The runaway winner was extending mobile operator connectivity indoors, with the second place coming in as performance and capacity metrics for user connectivity. Now, and this is to anyone on the panel in particular, are you finding that this is a common question, maybe Dr. Boo, that people are asking to extend their mobile operator connectivity indoors, or are you seeing more outdoor requests? And how does this reflect on your findings so far?
I think that matches exactly what we're seeing. Number one question we always ask is how my cell phone coverage and cellular coverage is not ideal in that building, and I want to improve my cell phone reception or whatever smart devices be able to talk to the cellular network. That's really the number one concern. we're facing right now.
Fantastic. The second poll we had was, which technology are you most likely to invest in the upcoming quarters or years? This one was a little bit closer, with the number one being extending, adding, or renewing DAS coverage indoors, with the second being very closely CBRS-based private LTE for critical infrastructure. Mehmet or Jamel, in terms of looking at extending DAS coverage or looking at now extending into CBRS-based LTE, is this also becoming more the norm, or are you seeing a little bit slower adoption for CBRS or faster adoption versus DAS coverage? Anything in particular come to mind?
Yeah, in terms of extending the mobile coverage, I kind of went over that in my presentation. We see it, device kind of specific. For the devices which are owned and operated by the enterprise, we see that initial deployments with CBRS today can easily address those. You can also have devices with dual SIMs, so that you can have those devices prefer the CBRS network when they're in the enterprise and then fall back to the macro cellular network when they leave the enterprise. Now, for the customers and visitors with the bring your own device type devices, which may be locked to a certain operator, then you need to have that interface on the back end with the operator. And I would say we are in the earlier stages of those kind of engagements with the mobile network operators and localized CBRS networks. But we'll see more of that use maybe in 2021 timeframe. Meanwhile, many enterprises are going ahead with the private use cases for more predictable network for their mission critical applications.
All right, fantastic. Now, also, as you can hear, and most of you will have heard during the presentation, the little sound that pops up. That is the sound of people asking questions or chatting. So it's been happening throughout this presentation, which is fantastic. We have fantastic questions and answers as well. Encourage you to keep doing that, even offline to us here at IBWave, CTS, or Salona. In this case, and this is for any of the presenters in general, especially since I have my slides up. Are there any questions that stand out to you that maybe are awaiting an answer, or something that you'd like to add a little bit more onto from what Oser or yourselves have contributed already in the question section?
Maybe we can go over the questions and then start answering them live. There's so many questions. I don't know if you want to do that.
Yeah, there are quite a few. Any jumping out to you that you'd like to address?
So there was a question if there's a similar CBRS system in the UK. I think the UK, Germany, and I believe Netherlands and Japan are looking to deploy similar private or shared spectrum. Here in Canada, we're still waiting for the organization that's handling that to announce something. So worldwide, it's slow. So the US is leading, and I believe Japan is second.
Yeah, I was just answering exact same question, Jamal. You're absolutely right. But actually, Germany opened up the 3.7 to 3.8. It's available commercially now. UK opened up 3.8 to 4.2, and 2390 to 2400 for LTE. Japan has opened up 100 megahertz already, and there are a bunch more coming up in 2021. I think many of those major countries either already have initial bands opened up for private use, such as CBRS, or very close to opening it up in 2021.
All right, fantastic. Any other questions you'd like to address? I know that we're nearing the top of the hour, and thank everyone for sticking with us so far. Anything else you'd like to address on this one, or we can follow up with individuals afterwards?
Yeah, honestly, so many questions out there that I guess the presentation availability to download afterwards.
Correct. Presentation will be available. Yep, absolutely. Absolutely. So in the interest of time, what we'll do is we'll send out the deck, of course. It will be available to you. Also, the on-demand version of this webinar as well will be available. So please come back if you'd like to hear it or see it again. But the deck is available. What we'll do is we'll try to address these questions either in chat or get back to you individually with the answers as we have them. Please do feel free to reach out to us on our social media platforms, also on our website. I want to, thank you for spending time with us and also thank the presenters for their fantastic content today. Do reach out to us on Twitter as well on Solona.io, or also come back to this or past webinars. We're always happy to have you come back and see it. I know that IB Wave has some fantastic webinars, one which we just participated in, cracking the code of Enterprise 5G a few weeks back. So feel free to check that out. And with that, we do thank you again for your time and your consideration, and please don't be a stranger. We'd like to have you come back anytime. So anything else, presenters, before we let you go?
Well, thank you so much for attending, everyone. It was a great pleasure. Thank you.
Thanks,
Thank you,
Mark.
guys. Don't hesitate to contact us if you have questions. I know there were so many questions, and we'll be glad to answer that via social media or via emails or just LinkedIn, Twitter. We're here to help. Thank you, guys.
Fantastic. Well, on behalf of Solona, CTS, and IB Wave, thank you and have a fantastic day.